Hello students, welcome to Educate. In this class, we will discuss about the atomic structure. There will be various theories regarding the structure of atoms. And the first theory proposed, that means the first scientific theory proposed about the atomic structure was by John Dalton. Before that, in India also, number of saints, that is particularly the Kant, has proposed about the atomic theory, but that was not the scientific theory. Now let's see about here atomic theory. First atomic theory was proposed by John Dalton. Okay, the first atomic theory of matter was first proposed on a film scientific basis by John Dalton. Okay, that was just the introduction. What he told, John Dalton has proposed that there will be a smallest particle, a smallest indivisible particle, which was called atoms. And what happened here in the atomic theory? Various theories have been proposed. Some theories, some theories explain about some phenomena, and to some theories, that means some theories explain about other phenomena. Let's see about this one here. So that was John Dalton's atomic theory, and towards the end of 19th and 20th century, this has been felt that it was proposed that the electron, that atom is made up of electrons, protons and neutrons. Okay, actually the electron, proton and neutron are the fundamental particles. Till now you have studied that the atom is made up of electron, proton and neutron. The atoms are made up of electron, proton and neutron. About that you have studied. But they are the fundamental particles. Fundamental particles means they exist permanently. Electron, proton and neutron, they exist permanently. But there are other particles also. There are other particles also present in the atoms, like mesons and so on. But their half-life period are less. They converge in each other. So they are not the fundamental particles. The electron, proton and neutron are the fundamental particles of atom. Okay, so that's right. Now let's see what was about that discovery of electron, discovery of subatomic particles. So they are electron, proton and neutron. They are also the subatomic particles. Electron, proton and neutron. Someone will tell, okay, which is the smallest particle of any substance. So someone will think electron, someone will think proton and someone will neutron. But actually the properties of the electrons of every element will be same. The properties of proton of every element will be also same, and same as the properties of the neutron of every element are also same. So they are not the smallest particle of any substance. The smallest particle of any substance is atom only, because the atom of that substance will possess all the properties of that substance. Okay, so don't consider that, okay, someone may think that smallest particle is electron, then why not it is the smallest particle of any substance. So, smallest particle of any substance is not electron or the proton or the neutron, because properties of all the electron, the proton as well as the neutron are same of irrespective of the substance. So, atom is the smallest particle which possesses all the properties of any substance. Okay, so electron, proton, and neutron, they are the subatomic particles. Now, discovery of electron. How electron was discovered? So let's see here the discovery of electron. That means the electron was discovered by cathode ray discharge tube experiment. Electron was discovered by the cathode ray discharge tube experiment. That is, who have firstly performed the cathode ray discharge tube experiment? That Michael Faraday. Michael Faraday, first of all, performed the cathode ray discharge tube experiment, and but he have not given any explanation about that. So J.J. Thomson proposed about that cathode ray discharge tube experiment and performed here and has been explained about that. So J.J. Thomson. So firstly, here not okay, here written anywhere. That is here. So that is cathodic discharge ray particles. What about this one? So that is here informative thing. Now, what is that? Cathode ray. That means here that there is a discharge tube that is called cathode ray discharge tubes. In that one, the pressure of inside the cathode ray discharge tube has been increased by evacuating the pump. So by evacuating from this one cathode ray discharge tube, the pressure inside the cathode ray discharge tube has been decreased. So a number of air by the discharge that is by the vacuum pump, the gaseous particles from the cathode ray discharge tube has been taken out, As a result, there will be few particles inside the cathode ray discharge tube and which exert very little pressure. So pressure inside the cathode ray discharge tube was decreased by evacuating the cathode ray discharge tube. Now here this is the cathode, here anode that has been connected through a battery, and that is high voltage battery. The range may be in the range of 2000 volt. You may imagine how much current is there. So that means high voltage battery has been connected there, and pressure here near about 0.01 atm. So how much pressure inside that cathode ray discharge tube, you may imagine, that is in the range of this one, in the range of 0.1 atm pressure was inside the cathode ray discharge tube, and the voltage in the range of 2000 volt was here connected through the electrode. Okay, what happened here? Actually, the electron comes through this one, through this battery, through this battery. The electron comes toward this side. Electron come. This electron reach the here at the cathode. This electron from this battery, the electron from the battery that reach to the cathode. So here, what happened? This cathode, and then after there is vacuum. So this cathode here, electron come, that get absorbed by the gases present here. This one here, high voltage there. So then after what happened? This electron starts traveling. Then after this electron starts traveling from cathode to anode. Since that this rays that exerts in the form of rays. So a rays, that means this electron starts traveling from cathode to anode, and in the that is here a ray has been produced there. So that rays, since this stream of electron form the cathode rays, and that rays has been, that is these rays has been originated at the cathode. That's why these rays were called cathode rays. Electron here comes. Now electron starts flowing from this cathode to anode, and in the so there be a stream of electron, and that's why there be the constitution of the cathode rays. As these rays were originated at the cathode, that's why these rays were called cathode rays. Now these rays comes at the anode here. So during that course here, cathode rays is there. Now when we observe about the properties of the cathode rays, then we will realize that these cathode rays are the stream of electron. How that is? Let's see here one by one. So let's see, first one is here. Cathode rays starts from cathode and move towards anode. Very simple here. It is summarized form. Cathode rays, the cathode rays starts from cathode and move towards anode. Obviously, since these rays was originated at the cathode, that's why these rays were called the cathode rays. Second one is, these rays are not visible. Like that of light. Light itself is not visible. You cannot find out the light. You cannot observe or see the light. But the light creates this sensation of vision. Without light, you cannot see any object. But light itself is not visible. Okay, so the second one is these rays themselves are not visible, but they behave okay. So like that of light is not visible, in the same way the cathode rays are also not visible. Its presence can be felt by certain observation, like it has when fluorescent or phosphorescent properties. That means when the cathode rays strikes to any substance that emits, that is called fluorescent properties or the phosphorescent property. Fluorescent properties and the phosphorescent properties had bigger difference. About that, we will discuss any other time. Right now, only you know that these cathode rays are actually not visible. We observe the cathode rays by certain phenomena, like when it falls on any material, then a fluorescent or phosphorescent material. So in this case, we can felt the presence of cathode rays. Light, there is a light or not, we cannot see light, but light is falling or not, that's we can find out that when light falls on a substance and we able to watch out the substance, then we will realize that there is sufficient light, and when there be no presence of light, there be darkness. So in the same way, when cathode rays strikes to a substance, then that substance glows, and in this way we can felt the presence of cathode rays. So cathode rays are not visible. Keep in the mind here, the cathode rays are not visible. We felt the presence of cathode rays by certain phenomena like fluorescent or the phosphorescent phenomena. Okay, that is here. Okay, here another one is taken here, that in your television tube, in your television, what happened? We observe the television, that means screen here, that means what is taking place and like that. That depends on the phosphorescent or the fluorescent phenomena of certain material. Electrons float through the electricity to the and comes to the television, and finally there be the bombardment of electron on the fluorescent as or the phosphorescent material. Fluorescent and the phosphorescent material, the electron produced, the electron from the electricity, that means source of electricity, that strikes to the fluorescent or the phosphorescent material, and as a result you could able to watch out the television. So in the television, we watch the television on based on the phenomena of fluorescent and the phosphorescent. Okay, so now there be some fluorescent or phosphorescent materials there is. That is not then after is here. So since the cathode rays is the stream of electron, so obviously when electric field or magnetic field, when electric field or the magnetic field will apply across the cathode ray discharge tube, then there will be deflection in the cathode rays, which verify that the cathode rays are made up of negatively charged particles. When electric field or magnetic field passes, when electric field or magnetic field passes through cathode ray discharge tube, then there will be deflection in the cathode rays, which verifies that the cathode rays are made up of negatively charged particles. Okay. Third one is here, the main point here is the properties of cathode rays. The properties of cathode rays do not depend on the gas taken inside the discharge tube, as well as also not depend on the material of electrode. This is very important point. That is, the properties of cathode rays do not depend on the gas taken inside the discharge tube as well as on the material of electrode. About that I shall write out there also. This one here. Okay, this one here behavior. Okay, this point here, third, straight line. So obviously as light travels in a straight line, in the same way cathode rays also travel in a straight line. That was here not so much important. As light travels in the straight line, cathode rays also depend on the cathode rays also travel in the straight line. And here electric field and magnetic field, when applied through through the cathode rays, there will be deflection in the cathode rays, which verifies that the cathode rays are made up of negatively charged particles. So one point, important point here, this the most important point about this concept is, write that here. These are the concepts which required for your CUT examination, obviously for the 11th class, and let's that there be some probability of asking this question in the NEET examination. IIT in the IIT main examination, there is probability of asking some question, but not so much frequently asked. But that means maybe 20% chance there is to ask in the IIT main examination. So that is here the concepts which require for the CUT examination, for 11th examination, 11th class examination, as well as for the NEET examination. Now then after is charge to mass ratio of electron. Charge to mass ratio of electron. So charge to mass ratio of electron, that was calculated by J.J. Thomson. What will be the charge to mass ratio? That has been proposed, or that has been done by J.J. Thomson. Okay, charge to mass ratio. So here it has been observed that here, this one here, tube, this is nothing, tube here, and that has been connected through a screen here. Here is a fluorescent screen. That means when the electron will strike there, it will start to glow. It will start glowing here. So electron here, this is anode here, cathode discharge here, this one is here. This anode is porous. Porous, so cathode ray will pass out. Electron starts from here, the anode wave is this one here negative charge, here positive charge. So this positive charge will attack the electron. This positive charge will attack the electron. So electron will originate at the cathode, and that will start traveling towards the anode. And since this anode is porous, so electron will pass to this one. So when the electron will pass here, then what happen? When electric field applied, listen here, this one, here is the positive charge, here negative charge. When electric field will apply, suppose first don't consider about the magnetic field. When electric field apply here, then what happen? This electron deflects towards the positive side. Obviously, cathode is negatively charged, so it will attract towards the positively charged. So it will attract towards the positive charge. So so there will be the deflection in the cathode rays. Obviously, when electric field or the magnetic field was applying across the cathode rays, then there was the deflection in the cathode rays, which satisfied that the cathode rays is made up of negative charged particles. And then after it has been realized that the cathode rays are actually the stream of electron. So when electric field was applying here across this cathode rays, then there will be deflection in this cathode rays, and that's the cathode rays falls on strikes at the point A. Again, this magnetic field, north pole and south pole here, magnetic field applied here. So what happened when magnetic field apply across any charge, when any charge be in the motion and magnetic field apply there, so there will be deflection also. Fleming's left hand rule about that might be you have studied in the 10th class or 9th class. So during that course, what happened when magnetic field applied across the cathode rays discharge tube, then there will be deflection in this cathode rays, and this deflection was towards the here point C. So the cathode rays strikes at point C. So at point C there be starts glowing. When electric field and magnetic field both applies across the cathode rays discharge tube, then this cathode rays strikes at point P, and this point, so here point B, and here it starts glowing. On the basis of number of phenomena and other calculations, it has been found that the charge to mass ratio of the electron is 1.75 into 10 power 11 coulomb per kg. The charge to mass ratio. Okay, firstly the discovery of electron took place. Then after, firstly the charge to mass of the electron was calculated, and then after the mass of electron was calculated. Okay, so this one. Okay, the third point is here simple here. This one here written about the summary. Here the magnetic field when applied, then electric field, and if magnitude of voltage. Okay, when will be the more deflection? If the strength of electric field or the magnetic field applies across the cathode ray discharge tube, then deflection will be more. When electric field or the magnetic field, when the strength of electric field or magnetic field applies across the cathode ray discharge tube, then the deflection in the electron will be more. Okay, second phenomena, if the charge on the electron will be more, if the charge on the particle which is in motion will be more, then obviously that will feel more attraction towards the electric field or towards the magnetic field. So the deflection will be also more in that case. Third one is here, third point. Okay, then after is mass. Okay, so then after obviously lighter particles deflects more compared to that of heavier particles. So there will be deflection in the particles of cathode rays. Depends on the deflection in the particles of cathode rays depends on three factors, or deflection in any charged particles depends on in three factors. One is the charge on the particles. Second one will be, that means more with the charge on the particle, more with the deflection on applying the electric field or magnetic field. If there will, on applying the electric field or magnetic field, there will be more deflection if the charge on the moving particle will be more. Second one will be that second factor influencing was the mass of the moving particle. If more be the mass of the moving particle, then deflection will be less. So when electric field or the magnetic field will apply across the cathode ray discharge tube, then there will be more deflection if the mass of the moving particle will be less. And third one is, if the strength of electric field applying across the cathode ray discharge tube will be more, then the deflection in the moving particle, charged moving particle, will be more. In the same way, if the strength of magnetic field applying across the cathode ray discharge tube will be more, then the deflection in the charged particle will be more. So that was on which factor the deflection in the particle were depending. That is here. These points are that. Now the charge to mass ratio has been calculated by a number of calculations, and it was observed the charge to mass ratio will be 1.758820 into 10 power 11 coulomb per kg. Okay, so in the examination question may ask what is the charge to mass ratio of electron. So either you mugged up, or if you that one you forget during the examination. So what to do? So firstly, charge to mass ratio you have to find out. So charge on electron is 1.6 into 10 power minus 19 coulomb, and mass of electron is 9.1 into 10 power minus 31 kg. That is 9.1 into 10 power minus 31 kg. So after that calculation, you could find out the charge to mass ratio of electron. If in the examination question asks what is the charge to mass ratio of electron, then you can calculate. And asking the question about the charge to mass ratio is less in case of IIT main, and it is more in case of CUET and NEET examination. Particularly in CUET examination, there is more probability of asking the questions about the value of charge to mass ratio. That is. Now then after is discovery of proton and discovery of neutron. Firstly, there was the discovery of electron. So who should be credited about the discovery of electron? So that means who have performed the cathode ray discharge tube experiment successfully and have also given the explanation. So first of all, the cathode ray discharge tube experiment was performed by Michael Faraday, but he was not explained about that. That's why credit for the discovery of electron will not goes to the Michael Faraday. And J.J. Thomson has given the explanation about the cathode ray discharge tube experiment. That's why credit goes to the discovery of electron to the J.J. Thomson. So J.J. Thomson discovered the electron, Goldstein discovered about the proton, and James Chadwick discovered the discovery of neutron. So here I am writing here. Okay, how that experiment done? That's also explained here. But right now, what is here? Discovery of. Okay, that is here. Now, how's the discovery of proton? So this proton was also discovered by cathode ray discharge tube experiment. what has been done? Let's see here. Same to this experiment. Let's see about that. What was happening here? Cathode rays. So James Thomson have performed the cathode ray discharge tube experiment like this one. Cathode ray travel in from cathode to anode. What happened before that? Here a porous cathode was taken. Just like that, you have seen the chutney. Maybe you have seen. I think if you have gone in the kitchen, might be you have seen there is some vessels also in which lots of pores is there. That's called the chalani in the local dialects. Chalani. So like that. So that will be that chalani was connected with the here wires. So that was so this cathode was taken, porous cathode was taken. When the porous cathode was taken, then it was observed that the back portion, that means when a fluorescent screen was taken here, and this cathode, when a porous and cathode was taken and a fluorescent material back to the cathode, then it was observed that the back portions, this fluorescent screen also glows. Okay, so what happened here? So then after the Goldstein performed the experiment again more seriously, and then after he observed that here here of the about the cathode or rays travel from anode to cathode. A rays was traveling from anode to cathode. Here, that was taken here. It's a fluorescent screen that side. Okay, so that means here anode, and since that rays were originated at anode, that's why these rays were called anode rays. What actually is happening here during the experiment? That the cathode rays travel towards the anode. The cathode rays originates at the cathode and travel towards the anode. On the same time, some rays travel from anode, and that means some rays originates at the anode and travel towards the cathode, and those rays were called anode rays. So cathode rays travel from cathode to anode, and anode rays travel from anode to cathode. Okay, that was that was the experiment, and then after the characteristic of the anode rays were observed. Okay, so like cathode rays, the anode rays were also traveling in a straight line. In so much detail, you will not have to study in the 11th class. Like how the anode rays is made up of charged particles, like that. That were in the class 10th or 9th, in which chapter you have studied. So nowadays here we will discuss in the detail. There was not so much concept, that means meager concept, that was that particle, here it is. So kinetic energy was there and so on. So but here the some properties which asked in the examination, that is here. About that we will discuss here. First one is again for cathode rays were traveling in a straight line. In the same way, the anode rays also travel in a straight line. Okay, so first point here. So So what was cathode rays was made up of negatively charged particles. So here anode rays be the made up of the positive charged particle. Okay, so first one here, because cathode rays was made up of negatively charged particles, that's why that was originated at the cathode and traveled towards the anode. In the same way here, the anode rays here travels towards the cathode. So that is made up of positively charged particle. So need to write, right? Like that, cathode rays was not uh, observed by the naked eye. That means the cathode rays, human beings cannot see the cathode rays. In the same way, the anode rays will be also not visible. Like cathode rays, the anode rays are also not visible. This one. Okay, about that we have also discussed here. How that can be observed? That can be observed by the fluorescent screen or the phosphorescent screen. Okay, that also. That is here. Now the most important properties here. What is that? Cathode rays, the properties of cathode rays were not depending on. The properties of cathode rays were not depending on the gas taken inside the discharge tube. But the properties of anode rays depend on the gas taken inside the discharge tube. Okay, so that is the most important point of this topic. That is the properties of, unlike cathode rays, the properties of anode rays depend on the gas taken inside the discharge tube. Okay, guys, that where, so here from here the probability of asking the question is more. The topics which we have discussed, among all of them, the problem here, that is of the topic discovery of anode rays, the properties which we have discussed, among them, this one is the most important, and probability of asking the questions in the NEET examination as well as in the CUT examination is most from this topic. In the IIT main examination, the probability of asking this question is very less. Now let's see. Okay, about the charge, okay, about that I have told you or not. Okay, about that I have told you or not, let's see. Okay, first let's see what happened here. I am drawing the structure. Suppose a discharge tube here taken. Rough diagram I shall make. What happened here? The cathode ray here, that is suppose when you have taken hydrogen, H2. So what happened? This electron come here and electron flow towards this cathode to anode. Here negative charge, here positive. So electron will flow from this cathode to anode. Here hydrogen also get ionized. Here so hydrogen that will dissociate into 2 moles of H plus and electron. Again, inside this gas, the electron will release from the hydrogen. That will also travel from this cathode to anode. And this H plus ion, that will travel from this anode to cathode. So in this case, when hydrogen you have taken, then cathode rays is the stream of electron and anode rays is the stream of proton. The cathode rays is the stream of electron and the anode rays is the stream of proton here. Okay. Now when you take suppose helium, when you take helium, so what happened? Helium that when loose that become He2 plus and here 2 electron. What happened? This electron will constitute the helium, the electron released by the helium that will constitute the cathode rays. And this He2 plus ion, this He2 plus ion will travel from anode to cathode. This He2 plus will travel from, there will be a movement of this He2 plus from anode to cathode. So He2 plus will constitute the anode rays. The electron released from the helium will constitute the cathode rays, and the He2 plus formed will travel from anode to cathode. So guys, when you compare about the H plus and He2 plus, another gases also you may take like that, like sodium if there be sodium vapor. When here sodium vapor will be taken. Okay, let's see here of the sodium vapor also. Here not solid sodium I am taking, here is taken, that is taken sodium vapor has been taken here. So when sodium vapor will be taken, so sodium here, that will release the electron, so that will form Na plus and the electron. The electron will flow from, this electron will flow from, this electron will flow from cathode to anode, and the Na plus that will flow from anode to cathode. Now guys, you just tell, that means when hydrogen was taken, so here electron here, so electron released by the hydrogen or from the helium or from the sodium vapor, that will have the same properties. But the properties of H plus, the He2 plus, as well as of the Na2 plus, they will be different. So that's the reason the properties of anode rays depend on the gas taken inside the discharge tube. Okay guys, now then after is, now let's see here one topic about that charge on the electrons here. Okay, so charge to the electron. So R.A. Millikan has found out the charge on electron. So Millikan have calculated 2 points. That means 2 observation he have find out. One is charge on the electron and second one is mass on electron. J.J. Thomson have calculated E by M ratio. J.J. Thomson calculated, first of all, okay, obviously J.J. Thomson have discovered the electron. In addition to that, he also discovered the charge to mass ratio. And then after Millikan have calculated the charge on the electron as well as on the mass of electron. So when he calculated the charge on electron, so obviously E by M ratio, J.J. Thomson have calculated, and E he have got the charge on electron he calculated. So by M that can be find out. Okay, E by M is calculated already, so that can be find out. So that's point you keep in the mind that J.J. Thomson discovered the electron, the Millikan discovered the charge on electron as well as the mass of electron. So that's right. Okay, next point here is who have discovered like that. So J.J. Thomson discovered electron, Goldstein discovered proton, and James Chadwick discovered the neutron. These concepts are not so much important for IIT main examination. There is only 0.1% probability of asking the question in IIT main or JEE, what you tell. Okay, frankly speaking, yes, if that will ask, that will be in the form of a statement. Okay, so that was done. Okay, one point here left, that is when then someone may ask that, okay, anode rays has been discovered, then how proton has been discovered? So when the hydrogen gas was taken inside the cathode ray discharge tube, when hydrogen gas was taken inside the cathode ray discharge tube, then the anode rays were the stream of proton. Okay, so because hydrogen is made up of only proton and electron, hydrogen is made up of only proton and the electron. So when hydrogen get ionized, electron constitutes the cathode rays and the proton constitutes the anode rays. So H plus is actually the proton. After losing the electron from hydrogen atom, what's left? That is the proton. So proton was discovered, that is by when hydrogen gas, or here taken the lightest gas. So lightest gas till today is hydrogen. Till today the lightest gas discovered is hydrogen. So here that's why, and that time also the lightest gas with the hydrogen, obviously till now the lighter than that of the hydrogen, any gas has not been discovered. So that time also not discovered. So when hydrogen gas was taken inside that cathode ray discharge tube, then the anode rays were the stream of proton. So in this way, the cathode ray, the electron and the proton both discovered. Now how the neutron was discovered? Neutron, the discovery of neutron takes times. The discovery of neutron took times because that's the electrically neutral. And James Chadwick had discovered the neutron, and by Hawes he bombarded, the James Chadwick bombarded alpha particle on beryllium. Beryllium 11 here, he bombarded the alpha particle on the beryllium. So as a result, what he have find out that during that course, nitrogen formed and here a neutral particle. Atom number 7. Beryllium was bombarded by the alpha particles and he discovered a particle which was electrically neutral. Since that particle was electrically neutral, that's why he named it neutron. So here no charge but mass was 1. Its mass of neutron is slightly greater than that of proton. The mass of neutron is slightly greater than that of proton. So keep this information in your mind. Okay, and here this one formed. Okay. So James Chadwick have discovered like this by bombarding the alpha particle on the isotope of beryllium. As a result, okay, that is James Chadwick discovered the neutron by bombarding the alpha particle on the beryllium. He find out there was formation of nitrogen as well as of particles which was electrically neutral and their mass was slightly greater than 1. Okay, so 2 points you will have to discover. One here you will have to keep the information for that is more important for the again CUT examination and the NEET examination, and particularly in the CUET examination there is probability of asking the question that how the neutron was discovered. So this, James Chadwick have bombarded the alpha particle on the isotope of beryllium. As a result, there was formation of nitrogen and on neutral particles, electrically neutral particles, which he named the neutron. Okay, 1 point here, 2 point, 1 point this one, keep in the mind. One point you keep in the mind that alpha particle, what is that alpha particle? He2 plus, you know already about the alpha particle, that their atom, that means charge is 2 on the alpha particle, that is charged particles. Alpha particle is a charged particle and in that alpha particle the charge is plus 2 and mass is 4. So this alpha particle is nothing, that is He2 plus. So charge is 2 and mass on the alpha particle how much? Mass of the helium is 4. So that's why the charge on alpha particle is plus 2 and mass is 4. So second point, keep in the mind that alpha particle is He2 plus. Okay, guys, that was about the discovery of electron, proton, and neutron. And once this discovery done, then after the atomic theory has been proposed. So first one is Thomson's atomic model. In Thomson's atomic model, that time the neutron was not discovered. So J.J. Thomson had proposed the atomic theory firstly. So first atomic theory proposed was about the J.J. Thomson. Atomic theory means about the structure of atom. That was by J.J. Thomson. And what that theory is, and what then after once this theory get failed, then another theory comes, and what the other theory is. About that we will discuss in the next class. Till here, it's all for the today class. Thank you, Team Educate.